Cool. Well, let's go ahead and get started. I do think this is an exciting presentation we have in store for you. This is a MotherDuck and Dagster presentation on how you can go from a local development environment to production and have confidence in doing so. It will also be demonstrating how to use evidence for building dashboards. My name is Colton Padden. I'm a data engineer and developer advocate at Dagster Labs. I work there working on dog fooding our product, building integrations, making learning material. I've been in the data space for 8 or so years now, and I used to use Airflow like every day for like 6 years. And then after I learned about Dagster, I liked it so much, I ended up working there. So I think that kind of goes to show how much I like Dagster and the power of it.
Well, that's awesome. Well, howdy, I'm Alex. I'm a forward deployed software engineer here at MotherDuck, and I also do some blogging for DuckDB Labs. So I'm also, became a fan and then got to work on what I'm a fan of. So I spent 9 years at Intel, going from industrial engineer to data analyst to data scientist, and along the way helped build a self-service analytical platform. And DuckDB became a key ingredient of that. I became a huge fan, tweeted about it a lot, and actually got recruited to do some part-time work for DuckDB Labs based on Twitter. So very millennial of me being recruited by Twitter, but really excited. And it's been diving deeper and deeper into duck-themed databases ever since. So great to meet everybody.
Awesome. So let's start by talking about the problem statement. So in this presentation, we're going to share an example stack of using Dagster, MotherDuck, and evidence. But first, we want to outline what we're trying to solve here. So it's kind of like a known problem in data engineering and building data pipelines that working locally can be pretty difficult. And then going into production with like what you developed locally and having confidence is pretty tough. So some of those complexities that you might have is mocking your data sources, writing unit tests for your data pipelines. The scale of your data can be difficult to work with locally, and having like a good representation of what might be in production is a little tricky. And then integrating with external systems can be tough, especially if you're in an enterprise that's really locked down. Like you wouldn't have access to production Snowflake from your local machine. So having a way to have copies of your data set is really beneficial. So the proposed solution here is to use tools that really emphasize developer productivity. And some of these tools include Dagster, MotherDuck, and evidence. And all of these have kind of been taking a cutting edge approach and taking the learnings from software engineering and applying those to data engineering so that you can really have an efficient way to work with things on your local machine. So this is the proposed stack. As you may already know, Dagster is used for orchestration. MotherDuck and DuckDB will be used as our data warehouse. We're going to be showing how to use dbt for transformations. And then finally, evidence will be used for building a report with really nice visualizations. So first, I'm going to talk a little bit about what is Dagster. I recognize that some of you may have not used it, but Dagster is a Python data orchestrator that has an emphasis on developer workflow and productivity. And it has a lot of support for different integrations, including MotherDuck and dbt, it really allows you to like hit the ground running. It has some key differentiators from other orchestrators. And one of the biggest ones is the paradigm shift of working with assets versus tasks. So in Airflow, you might define these black boxes or tasks that run on a periodic basis. And if a task is a verb, an asset is a noun. So in Dagster, you typically define like a noun. Like if you're collecting data about ducks, you would have a duck asset, which can like correlate to a database table. But this paradigm shift really changes in how you can visualize this. And you can have like a full asset lineage, so you can see how everything relates together. And then you can also use some really beneficial features in like not scheduling things on an hourly basis, but having auto materialization policies where things are more reactive and you have sensors and things just trigger when upstream data changes. So Dagster is kind of like a modern data orchestrator that has a lot of really cool features that allow you to really integrate with the modern data stack. Going to the next slide. I also wanted to talk about evidence. So admittedly, for this demo, this was my first time working with evidence, but I was really blown away by how easy it was to work with. Evidence is a platform for building data applications and dashboards. And funny enough, it's powered by DuckDB WebAssembly. So it's right there in line with the MotherDuck folks. You write your dashboards in Markdown, and you can embed SQL queries and leverage components for these visualizations in that Markdown file. And we'll be showing some snippets of code on how that's done later in the slides. And I'll give a very brief overview of MotherDuck here, but then I'll hand it over to Alex. But you all are probably familiar with MotherDuck, but it's a serverless data warehouse powered by DuckDB. And it really helps with like the local development flow in that it has a hybrid query engine. And one of the key things in this demo is that it has feature parity with DuckDB. So you can use DuckDB locally and then MotherDuck in the cloud, and it's all the same code, which is really, really powerful. Okay, now I'll hand it over to Alex.
Fantastic. Well, thanks so much. Yeah, really excited. Dagster is pretty neat in that you can kind of specify your end result that you want as an asset. A lot like SQL, this is the shape of data that I want. And that's how my brain works. So I really like it. Let's get into it. So I wanted to talk for a couple minutes about MotherDuck, just because we're very new, much more recent than Dagster, and wanted to give you an idea of kind of who we are and what we're up to. So first question that I want you to kind of be thinking about is really, why are we building MotherDuck? Why do we exist? Why are we so excited about it? And it's really about rethinking the cloud data warehouse. So back in 2012, when the current iteration of the cloud data warehouse was being designed, things were a little different. So what's changed since 2012? And what will we do differently if we start today? Secondly, we'll talk about MotherDuck, some of our secret sauce, what we're excited about, and especially look out for ways that it aligns really well with the Dagster ethos and working with Dagster. So we'll tie it together along the way. And then based on that, once you have those ingredients of MotherDuck, at the end of the day, it's about solving problems. So what experiences become ducking awesome? And watch out for the puns. They'll get you. We're all about the duck puns. You can post your favorite duck pun in the comments. We'll read them live on the air. All right. So why are we rethinking the cloud data warehouse? Well, we have a couple things that we believe, and based on those and based on the data we've seen, we think that there's some serious shifts that have gone on. And the first one is that we believe that big data was mostly marketing. Big data is dead. And if big data is mostly marketing, what does that really mean? It means that the way you design a system shouldn't be focused on the scale of your data. It should be focused on your developer experience. And if developer experience sounds a lot like Dagster, it should. It's important, right? Your productivity, you're the one using the tool. And the more productive you can be, the more value you can add for your stakeholders and for your company. We also believe that since 2012, laptops have gotten a whole lot more powerful. How can we take advantage of that compute that you've already paid for that is 0 milliseconds away from you, no network latency? Likewise, laptops are powerful, well, so are servers. I can go on AWS, I can rent a server with a terabyte of RAM today. And you could not do that in 2012. So how would we design a system knowing that a single node is so much more powerful now than it used to be? So we've got a cool architecture for that. And then DuckDB is designed to be a friendly database. We believe everybody loves DuckDB, and we want to build on top of that and add to that with MotherDuck. So big data is just marketing. Well, how do we know this? Well, our experienced team has lived it. So our CEO, Jordan, was one of the founding engineers of Google BigQuery and helped build it and scale it. And at BigQuery, 95% of customers have less than 1 terabyte of data in BigQuery. That's not very big data, right? I can fit that on my laptop. It's hard to call 1 terabyte big data these days. And so really the popularity of BigQuery, maybe it's not about the size of the data, maybe it's about something else. Maybe it's about developer experience. Likewise, at Single Store, 80% of customers of Single Store use the smallest instance size. And they kept asking, can we have a smaller one, please? We just don't need the instance size we already have. Gartner, A16Z, Ederson Horowitz, they agree as well. Big data was more marketing than reality. So what would we do differently? If big data is dead, which is a very clickbaity way to say it, but we believe it, we would make data easy. DuckDB does this very well. The analogy we like to use is a hamburger. Traditionally, the database research community focused on making an amazing hamburger patty, which is a database engine that returns your query very, very quickly. It does the calculation quickly. But they tended to ignore the full experience. It was hard to get data in and out. So import and export were very slow. Um, and what that feels like in a burger is, a really great beef patty with a soggy bun. You're not going to have a great experience. It all needs to work together. So how does DuckDB do this? DuckDB is really easy to install. In Python, it's pip install DuckDB. It's precompiled for all the various operating systems and architectures, and it has no dependencies at all. So you can add it to any workflow seamlessly. It's like 20 megabytes of a binary. So really easy to slot into every Dagster workflow you've got. And it does work very nicely with things like pandas, arrow, and polars, but they're not required. We can work with them without depending on them. It also runs everywhere. Runs on your laptop, runs in the cloud, runs anywhere you'd like to run Dagster, and it even runs in your web browser, as we'll see with evidence. Not only that, but you can query data frames directly. DuckDB is an in-process database, meaning it's running in the same memory space as your host application. So all the variables that Dagster sees, DuckDB sees. So if you like data frames, but occasionally you want to use some SQL or vice versa, you can mix and match throughout your Dagster pipelines. So it's really nice to have that seamless interoperability. And when you're using SQL, DuckDB is truly the friendliest SQL syntax in the world. Um, they're pushing the dialect in ways that simplify it, and yet they're also, you can use kind of the Postgres dialect standard that's been there for a long time. So if you like the standard, use the standard. If you want to simplify, they've got some great enhancements to SQL. So how do we build on that at MotherDuck? We believe in making data warehouses personal. We are offering Git-like operations for your database. So zero copy clone, branching, merging, and I'll talk more about that on the next slide. We're also serverless, which means that you only pay for exactly the CPU and storage that you use. Not the whole time that our instance is running, literally just the CPU cycles that you use. And this is great if, say, you have a big data job in Dagster, and you have a very sporadic BI workload, maybe powered by evidence, throughout the day. You don't want to keep a large instance running all day. You don't want to size your instance as really large for your BI workload. This is going to dynamically adjust to exactly what you need for the workload that you have. We can also even pull from Postgres and MySQL directly with dbt alone. This is a really great on-ramp as you're getting started. It's also great if you have a simple data environment. Fundamentally, at MotherDuck, we believe that there's a large swath of people that aren't really well served by the existing cloud data warehouses. And a lot of those folks have a simpler environment and they just want to get up and running and have things be easy. As things get more complicated, bringing in Dagster, bringing in other ETL or ELT tools makes sense, but we want to keep it easy to start. Fourth, we're very focused on local development powered by DuckDB. We'll see that we're even pushing the envelope here with what we call our dual engine setup, but local development by itself just makes developers so much more productive. I love being able to do things in my local environment, not having to spin up a cloud instance and having full control over that. So how about those Git operations? So what does that look like? Well, today we have the ability to do a zero copy clone of any existing database. So if you want to run a development pipeline, first step, copy production. It happens instantly. And then you can run your entire pipeline in a total environment, which really helps. We've also laid the foundation, though, for having full branch merge semantics, where I can actually branch a database, make some changes, and then merge it back. And the nice thing about that is I don't have to rerun my job when I deploy to production. My deployment step is literally just replace production with dev for instant deployments to production. We're also going to support full time travel, where you can go back to a specific point in time and recreate your database. No more, oh shoot, where'd my data go, right? Just wind back the clock. So this is really about the database experience. This is not about that burger patty of how fast can I get it done. It's how easy is my job when I use this database? How much value can I add for my company? So our other tenet is that if local compute is powerful, well, let's move our work locally. So we're going to peel back the covers. We're going to look under the hood a little bit of MotherDuck. And we call this dual engine execution. And we'll look at kind of three ways. The first way is kind of a traditional, if you're processing your data all in the cloud. So whenever you connect to MotherDuck, you use the DuckDB driver. All you need to do is change your connection string. and we will auto download the MotherDuck extension and you'll connect to the MotherDuck cloud. What that means is though, whenever you connect, you're using that DuckDB driver. And what's neat about DuckDB is the entire engine is inside the driver. Your ODBC, your JDBC, your Python client, they have the whole engine right in there, which means we now have two places where DuckDB is running, wherever you connected from and our server, and we want to use both. So the first step, whenever you connect, we'll go ahead and download our catalog. So where are your tables? Where are your columns? And when you run your SQL statement, we can figure out where does this need to run. And if it needs to run in the cloud, we'll send that query plan over to the cloud. It'll run and bring you your data back. However, by having that catalog local, by having that whole engine local, some queries can run entirely locally. And so you can see this in evidence, for example, when you're filtering and slicing and dicing your visuals, that can be entirely local. We don't have to wait for that network latency to go all the way back and forth to the server. So you can get instant results. This also works really well in a pipeline. So let's say your Dagster pipeline is to pull in some new data that you want to then upload to your central warehouse. Well, you're probably going to want to check on that data first. You're probably going to want to test it. And if your tests have to be run in your cloud data warehouse, you're going to really watch the costs there, right? You'll be very careful about how many tests you do on your data. If your tests are entirely local and they run instantly, maybe you'll test the heck out of that data before you put it in the cloud. That's another case where that local horsepower is really helpful. It also works great for caching. Let's say I have a result set and I want to play with it. I want to do a lot of data science work. I want to have a Dagster pipeline to take my raw data and turn it into intelligence, right? You can do that post-processing locally rather than using cloud resources. And even nicer than that, you can actually run one SQL query partially in both places. So let's say you care about a data frame in your local environment and you want to combine it with a lookup table in the cloud. What we'll do is we'll check which of those tables is bigger and we'll push it to the right node and do the join. So you can combine local and remote data even in the same query seamlessly. So this is really exciting. We want to lean into this and make it be really intelligent. A lot of cool potential here. All right. Servers are also enormous. So what should we do differently? Well, we should scale up because scaling up works much better now than in the past. So let's take a brief look back to the past, back to 2010. One of the most influential papers about data systems design was the Dremel paper from Google. And it used 3,000 nodes in concert to answer one analysis. Fast forward to 2024, you can rent a single node on AWS of a pretty beefy size. Let's compare it. Let's see how that compares to 3,000 2010 nodes. Well, it turns out that one node has much more CPU power, much more RAM power, more SSD cache space, more RAM bandwidth, more SSD bandwidth. The only spot where one node isn't better than 3,000 is on network bandwidth, and that's about to change with 800 gigabit per second Ethernet. So one node can be equivalent to 3,000, except for that last bar there, the cost, where it's much lower. So scaling up suddenly becomes incredibly viable. And this Dremel paper helped design a a decade worth of database systems. So maybe it's time to turn the page. Another area where if the cloud can scale up, how would we behave differently? In this case, the status quo is that you kind of have to manage how you bin pack your workloads. So you'll probably start out putting everybody on one instance, and then you'll turn the knob to make that instance as big as you can. And at some point, one customer is going to get much bigger, and they'll be, too big to fit on that instance. And then you're going to have to separate them out into a separate instance. And that might happen maybe with your top 5 customers, maybe your top 10. Suddenly you're managing a fleet of instances. How can you rebalance? How do you resize? It gets complicated. With MotherDuck, we're going to do that on your behalf. By being a serverless platform, we will create exactly the runtime that you need, and we will do the bin packing on our side. And we'll even do bin packing with other customers. So that'll give us the scale that we need, the efficiency that we need to really provide you a lot of value. Plus, we'll give you statistics by user. How expensive is that one user that does the full refresh? How about that one pipeline? Maybe you take a look there and you use some incremental features in your pipeline. So having that individual user attribution is very helpful. All right, what is it that people love about DuckDB and how can we enhance that? First of all, This is a bit of a vanity metric, but we wanted to kind of make the case that we think DuckDB is well loved, right? So this is our GitHub star history of DuckDB, uh, and we love the shape of that trajectory. We're above 16,000 stars now. And this is how DuckDB pitches the DuckDB open source library from its website. It's simple to install and deploy. It's portable and runs everywhere. It's feature rich. It's got an amazing SQL dialect. You can even read and write Parquet and JSON, even back and forth to S3. And then all the way down here, bullet point number 4 is that it's fast. And that's aligned with how we think, right? Developer experience is more than just performance. But don't be mistaken, DuckDB is in first place in several different industry standard benchmarks. So it has the speed, but it also has the developer experience. It is extensible as well. That's how we work at MotherDuck. We're an extension. And that allows us to keep writing the great improvements that the DuckDB team over at DuckDB Labs and in the community are making and stay on board as DuckDB rides that wave. And of course, DuckDB is open source. You're welcome to use it wherever you'd like. So any Dagster pipeline, you can have DuckDB right in there. It's MIT licensed. How do we build on that with MotherDuck? One of the fundamental limitations of DuckDB is that it's primarily a single player database. You can't access it from multiple processes. So in Dagster, it's very common. You want to spin up multiple processes while you're orchestrating. With open source DuckDB, you can't have those all be communicating together at the same time. However, with MotherDuck, you absolutely can. And that really allows it to scale in complexity. You can also share it with your team that way. We have some sharing features that we've added in MotherDuck, allows you to really easily share your data. And because we're in the cloud, you can scale with the cloud. You're no longer limited to your wherever you are currently running DuckDB. And then DuckDB runs everywhere, which means you can run it throughout your stack. We like to jokingly call it the modern duck stack. Duck puns will never end, don't worry. We've got a lot more where that came from. So your ELT, for example, can use DuckDB in your Dagster pipelines. You could even use those Postgres and MySQL scanners if you'd like. And there's other industry tools that do use DuckDB under the hood for ELT as well. We've got a DBT adapter, that can be DuckDB, and even your BI can be DuckDB, like with evidence. So what are the benefits there, right? Let's say you've got a dashboard and someone asks you to change something and you change it, and then 5 other people look at it and say, wow, I like that. I want that too. Well, you could take that same SQL code, put it in your DBT model, copy paste. And then, hey, wow, that got to be a really big query. Maybe we should process it when we ingest it rather than ingest all the raw data and then process it. Well, copy paste back to your ELT. So same dialect throughout your entire stack. Again, all about the developer experience. Okay, what becomes ducking awesome? Well, you get to explore your data at the speed of thought. If you have your data in that local engine, it's a 0 turnaround time to keep digging into your data. It means that you can quickly iterate through your pipelines. And then as a data team, you can develop locally and push to the cloud, especially combined with Dagster's branch deployments. It's a really powerful 1-2 combination to make that really seamless. And then your data apps, if you have a data app use case, you get incredible speed and interactivity. This is getting back to that in-browser idea. So when we're in browser, you have a database in the cloud and a database in your browser. So what does that mean? It means that once your data is in the browser, you can have 60 frames per second interactive experience. But you don't have to send all your data to the browser. You can do some processing on the server before you send it. So it's a really great combination there as well. And it's going to be faster, cheaper, better than what's available today. So let's take a quick look at that. Let me show you a demo. I will share my screen. All right. So this is a MotherDuck demo. This is looking at 10 million rows of data, of flight data. So the top chart is looking at how delayed your flight is. And then the middle chart is what time it takes off in the 24-hour day, and then how far that flight was. And the interactivity here is quite quick. So if I want to look at the flights that were delayed the most, those took off later. If I want to instantly move and look at flights that were early, those are not at the end of the day. So, but you can seamlessly move and you can explore your data faster than your eye can discern, right? That's not possible if you have a server round trip. It's not possible if one query takes 5 seconds. So these types of experiences that you can provide for your customers, for your stakeholders, are made possible by having a database on the server and a database in the browser. Let me jump back to the slides. All right. Well, thank you so much for diving into MotherDuck with me. Feel free to ask your questions in the chat. I will get to those in the Q&A. And I'd like to turn it back over to Colton to do a project walkthrough.
Awesome. Thanks so much, Alex. Those features really are pretty incredible. As I mentioned earlier in the presentation, we're providing a full stack example of how you might use these tools. And I wanted to briefly go through some code snippets of that project. You can clone a repo with the code by going to this bit.ly URL or scanning the QR code. You're welcome to open an issue, a pull request on that repo, or if you have any questions, feel free to message me on the Dagster Slack or on GitHub directly. But we hope you find it interesting. So here's an overview of the pipeline that this project builds. What we're looking at here is the global asset lineage that you would see in Dagster. And this is just an overview of what like the development pipeline would look like. So we're looking at Cornell's project feeder watch data set. We're pulling in that raw CSV data. We're preparing it with DuckDB and doing some transformations with dbt. And you can see we have assets for those dbt models as well. And then finally, we're building a report with evidence as the last step. And with Dagster, as you define these assets and integrate with dbt, you can get a full lineage of how everything pieces together. When we go to production, funny enough, the code is identical. Thanks to the feature parity of DuckDB and MotherDuck, it's the same exact code. You just have to change an environment variable, and we'll show you how that's done as well. But now you can see that now that we load the CSV file, it's being loaded into MotherDuck, and those transformations are happening with MotherDuck as well. And you can get that full performance of the cloud. This data set is, I think, around 12 gigabytes, so it could work just fine locally. But you can imagine how, as if something were to scale up or you start to get hundreds of gigabytes, you wouldn't want to run that entirely locally, and you would be better off leveraging something like MotherDuck and their query engine. This is what we'll be producing. This is a snippet of some of the dashboards that we've created with evidence, and you can see just how slick these visualizations are. So we're looking at a calendar heat map of duck observations, and then a state heat map of duck observations. You can see there's a bunch of white space there in the middle, and that's because this Cornell's Project Feeder Watch is seasonal, where it goes from winter to spring. And then you can see we get a lot of observations of ducks down in Florida. I don't know if that's because there are more ducks down there or just people who are interested in observing ducks, but that's kind of funny. And this is the project structure. The text might be a little bit small, but you can see it's comprised primarily of three things. On line 7, we have our dbt project, and that's where all of our transformations are defined. On line 16, we have a folder, and that's our Dagster project. So we have some files in there like assets.py, resources.py, and I'll talk a little bit more about what those are in the following slides. And then finally, on line 23, you can see we have our evidence project where our reports are defined. We also included a makefile in this project with some directives for easily installing dependencies and building your project and dependent dashboards. Cool. So now let's go over the code a little bit. This is going to be a high-level overview. I don't expect people to understand everything, but I think it's good to get this overview before you look at the code in the repo itself so you know what to look for. Awesome. So first things first, I'm going to talk about a Dagster concept here called resources. And resources really are the fundamental building blocks of building a pipeline with Dagster. And it happens to be how we connect to MotherDuck and DuckDB. So we define this DuckDB resource, and we pass it in an environment variable. And this is a wrapper around the DuckDB client. And because we're defining it as a resource, we can then use it throughout all of our assets in our code base. And this is a really nice way to build reusable code that you can share. In the snippet below, you can see our environment file where we specify the DuckDB database. And this really is where the magic happens in this project demo. So this DuckDB database can either be a local DuckDB file, or it could be a MotherDuck connection string. And that really is the only thing you have to change. And then your Dagster project will be either running on a local DuckDB file or MotherDuck. Same with your DBD project and evidence. Now I kind of want to talk about how we build assets. And the key takeaway here, I don't expect you to fully understand all the code, but it's just Python code. We're defining a function that takes in a couple of parameters, and we throw an asset decorator on top of it. And that's how you register an asset within Dagster. And as you can see, we're passing in a parameter to this function called DuckDB, and that is that DuckDB resource we defined earlier. You register your resources and your assets as a definition, and then you will have these resources globally available. They're injected into all the assets. But other than that, when you start to look at the code within the body of the function, it's just like any other Python code you would expect, where we get a DuckDB connection. We're loading that CSV file using the read CSV auto function. And then we're querying DuckDB again to get some metrics that are then returned from the function. One thing that I want you to take away from this is that the Pythonic nature of Dagster pipelines really lends them to that local development flow and writing unit tests. You could imagine that you could mock this DuckDB resource and then write very thorough unit tests for all of your assets in your pipeline. And then finally, you see that we're returning a lot of metadata related to this asset as well. And that eventually gets propagated into the Dagster UI, which I'll show you on the next slide. Yeah, so we're looking at the global asset lineage again, and I've selected that species asset. And the text is pretty small, but on the right, you can see we get to see the number of rows and along with other metadata associated with this asset. And also we've built some visualizations of that metadata as well. So you can kind of see how things change over time. And that's all out of the box with these assets. Dagster Plus actually just launched yesterday, and we've offered even more features around this metadata, including a full data cataloging solution within Dagster so that you can easily go and find where your data is through this metadata. It's really, really cool and powerful. Cool. So that was our assets that we defined just using Python code. But I also wanted to briefly talk about how we're integrating with our DBT project. We have a really great DBT integration that's able to extract all of the models from your project and visualize those alongside your other assets within your global asset lineage. So you can see all we're defining here above is using this DBT assets decorator that was a part of our integration. We pass our manifest file for our DBT project. And that's it. You see on the right, our models are just as you would define any other model using DBT. But then on the left, you can see how it all pieces together, and you can define upstream and downstream dependencies on these DBT models, which is really powerful. For these DBT models, we have like an all birds model that is then referenced by these more derived top ducks by region, top ducks by state. And you can see that lineage is actually represented in the Dagster UI. I just wanted to show you a quick snippet of the SQL for one of these DBT models, just showing you that it really is just a normal DBT model. We're not requiring any front matter or some kind of metadata definition to determine this lineage of the DBT model. It's just a normal reference to like the upstream all birds model. Cool. So that was a very fast overview of Dagster and how you define an asset and use resources. I encourage you to check out the quick start for Dagster and the Dagster documentation for more details there. And you're also welcome to message me with any questions. But now I wanted to talk a little bit about evidence. So evidence, powered by DuckDB, is this BI visualization tool. And what it does is it has connectors for all sorts of databases and warehouses. Snowflake, MotherDuck, DuckDB, Google Sheets, Postgres. I feel like if you name it, they have connectors. And what it does is it caches the data that's relevant to your visualizations as Parquet files, and then uses the DuckDB WebAssembly library to then visualize that. Here's an example of how you would define a visualization using evidence, and it's just Markdown. This was one of the coolest things I think of this demonstration project is how easy it was to get these very slick visualizations using evidence. So you can see we have on line 16 through 28, this code block where we're defining SQL. And then on line 8, we're using this calendar heat map component, and we're able to reference the SQL that's defined below. And then you can use the columns from that query in the component itself. And then on line 4, you can even see you can embed like values or smaller components directly in your Markdown as well. And this is all it takes to produce a really elegant dashboard with Markdown. I also wanted to demonstrate that we are able to build this dashboard from Dagster itself. Dagster isn't a CI/CD tool, so I don't know if I entirely condone this practice, but I thought it was really cool just to show the flexibility of Dagster assets being Python code, so you can really do anything. But here we're calling the npm command that evidence requires for installing dependencies, pulling those sources locally into Parquet files for your dashboards, and then building the static HTML and JavaScript that you can then deploy as a website. So we were able to define this evidence dashboard asset at the very end of our lineage to then produce this dashboard, which I thought was really slick. And you can also see in this asset definition, we specify the dependencies being this dbt birds dbt asset. So that's kind of how we get that lineage going. One thing that I looked at while exploring this feeder watch dataset was the least observed ducks, and these are some pretty cool ducks. The Muscovy duck on the far right is absolutely wild looking. I've never seen anything like that before in my life, so I thought you guys would like to see it too.
Ducks can be beautiful.
Yeah.
They're not just goofy, they're also beautiful.
Yeah, sorry, these are all beautiful ducks. Cool, so I wanted to go back to the pipeline just as a review. We didn't cover all of the assets here, but we did kind of dive in a little bit in how you would define them. But here you can see the overview of the pipeline. We're downloading CSV files from Project FeederWatch from Cornell University. We're using some Python assets to take that data and load it into either a DuckDB or MotherDuck database. We're using dbt to transform it, and then we're building an evidence dashboard. And that's it. I've included some additional links and resources for you all. There's a DuckDB integration for Dagster. There's an evidence integration for MotherDuck. You can see they kind of all fit together very nicely, and they all have integrations for one another. I also included a link here to the evidence core concepts page, as well as Project FeederWatch if you want to start observing some ducks yourself. And then also a link to the MotherDuck docs themselves. Awesome. Thank you so much. And now I'm going to open it up to some questions.
Thanks for the existing great questions in the chat as well. But yeah, happy to answer any other ones you have.
Interesting. We see this question. Oh, you already answered Tim's question about the timing out. Okay. I don't know if you want to reiterate anything, Alex.
Sure. Yeah, I'll wind it back a little bit. So, a couple great questions. Thank you. So we had some questions around the number of ducklings in MotherDuck and how do you specify the number of ducklings? So the way to think about it is really each user is going to get their own duckling, their own environment. And you can size that however you'd like. So today we're in beta. We're excited to be going to general availability before long. But as we're in beta, that's something where you send me an email and I'll bump up your instance size. But starting in just a couple weeks, you'll be able to turn a knob to be able to bump up the size of each individual user. And so you can control that horsepower that they're allowed to have. And then each user that you have can have a separate set of horsepower. So that works really well if you want to have a user for your bulk data load job and a separate user for your BI workload. And each user of your BI tool can have their own user. So really a different model that we think scales really well. You know, as you add users, they just get their own duckling, and it just scales as your usage scales. Let's see.
I do see this one question from Ali about an example of using a partitioned asset from Dagster. This demo project doesn't do any partitioning, but Dagster does have a very featureful partitioning concept in where you can have time-based partitions or even categorical partitions. We have some examples of that in our documentation that I believe you could find pretty easily through our search, but this project doesn't do that.
Awesome. Well, Gabriel has a great question. Could be Gabrielle, but Thank you, Gabriel. How would you go about connecting a MongoDB hosting in Atlas to MotherDuck through Dagster? Um, in terms of the getting into MotherDuck part, really, once it's in a format that DuckDB can read, then you can upload it directly to MotherDuck through DuckDB, just through an insert statement. So you basically, if you can read it into DuckDB, you'll insert it that way. The step I know less about is how to get it from Mongo into that step. But if you can convert it into a data frame, really of any variety, like Arrow, for example, Apache Arrow or Polars or Pandas, that is a good way to do it.
Yeah.
Colton, what would you add?
Yeah, that's a good point. I'm not sure if it's supported with our Sling integration, but we do have an integration with Sling that's meant for database replications. I'm not sure if MongoDB is supported. I think it might be, but I would advise you to check that out. And then you would just have to define some YAML of the source and sinks, and then it would be able to handle that like incremental loads and full loads for you. Yeah, I suspect there may be some tools out there, existing tools that you could use that have integrations with this ecosystem.
And Sling has Mongo, so right
Nice.
on, Colton. I tossed a link in there to the connectors that they have. There's both a Mongo one, a DuckDB one, and a MotherDuck one. So,
Oh, that's awesome.
um,
Yeah, you should check that out.
and I've tested the Sling connector. That was me. I know it works. I've done it. So give it a shot. Let us know.
Thomas asked, so one decorator dynamically composes the lineage from the DAG. What happens if you want to customize things like weather, tester, blocking, downstream models? I presume this is specifically for our DBT integration. And we have this concept of a DBT translator. It's this class that you implement where you could have conditional things depending on a specific model. And you could use that to customize things on like the tests that run. Also, you could use your DBT selectors to kind of like break things down into different subsections. So you could have like a tag of your DBT models that runs in one group of assets, and those are all blocked by some downstream test. But you should be able to leverage the like upstream dependencies and downstream dependencies of your assets in your DBT model selections so that they block before anything happens further downstream. You're totally welcome to hop on the DBT integration Slack channel, and we can assist you more if you're curious on that.
Very cool. Well, we can just trade back and forth. So Ed Ruiz had a great question about how MotherDuck decides to use local versus cloud compute. And does it depend on specific queries? And does it require data to be in the cloud? So that's a really great question. Today, we have all the infrastructure set up to make some very interesting decisions. Today, we've got a couple heuristics in place. So the future is very exciting. What we have today is looking at mostly data locality. So if your data is already local, we do our best to keep it local. If your data is already in the cloud, we'll do our best to keep it in the cloud unless you deliberately bring it down to cache it locally. So today it's mostly that kind of heuristic and then giving you the capability to decide if you want to push to the cloud or pull local. So you have some levers to do that with. What we're working on, we're doing some research, is having this be in the full cost model of the database. So that is where it is. We're basically the same way a database decides what type of join to do or the order of operations within your SQL query, that same process is going to decide where should it run. So it really is fully automatic, fully, behind the scenes where you won't have to worry about it. And we're looking at things like how fast is your network speed? How many cores do you have on your machine? How busy is your machine already? How much RAM do you have? And really look at that to balance the workload. So a lot of exciting possibilities moving forward. For now, we put a lot of that power in your hands.
Awesome. I see one more Dagster question. Ali asked, shouldn't the best practice for the DuckDB resource be used in an IO manager? And it's actually interesting you ask that. We're making an effort to move away from IO managers, actually. We found that the paradigm of IO managers didn't fit as well as we'd like into the overall narrative of how we want to define assets. So the best practice right now is actually to use the resource from your asset. That being said, IO managers are also totally a way to do this. But right now, the way our documentation is leaning, we would prefer that users would use it from a resource and then in their asset. But that is a good point, and it's good that you brought that up.
question from Thomas O'Neill. So what things are DuckDB and MotherDuck still bad at? The easy questions. Thank you. Very good one. And what should I not be planning to use MotherDuck for in a year? So kind of what are the long-term challenges with our architectures? That's a very good question. So right off the bat, we're a SQL-oriented relational database for analytics. So if you have a very transactional workload, we're not a perfect fit. Likewise, we have great JSON support and nested structure support. So we think we handle most of the NoSQL use cases, but it depends on how far down the NoSQL path you are. So that's another consideration. We're also, we're taking DuckDB, which is fundamentally a single player experience, and we are stretching it into multiplayer. So we're very good if you have, separate users accessing a BI dashboard works amazingly. If you want to do, sub 5-second ingestion from 10 different streams at the same time, that's a stretch for our architecture today. We can do some simultaneous reads in that type of format. We tend to like it as micro batches. So every couple of seconds, insert a batch. But true, sub 1 second latencies, streaming, that's not what we're targeting either. So if you have a lot of data streaming in, we recommend micro batching. And then transactional. We like Postgres. We're big fans of Postgres around here. Thank you for the easy question. And Archie, thank you for chiming in with an answer. You're exactly right. It is not an operational database. You're right there. I would say also that's also a great point, Archie. We target specifically somewhere in the 1 to 10 terabyte range of data scale in terms of the data you want to query within one query. It's okay if you have a whole bunch of data stored. We're storing it in the cloud. We can store as much data as you'd like. But if you ever want to run a query on, 100 terabytes of data at the same time, that's not what we're built for. So if you really have petabyte scale, if you're really, web scale, as the old joke goes, that will be a stretch for us. But we do think that, the classic disruptor models at play here, where we are able to scale up more and more over time, and we'll start to eat into larger and larger workloads. But our belief fundamentally, based on the data we saw at BigQuery, at Single Store, there aren't that many petabyte workloads. And even if you have a petabyte workload, you don't want to run your dashboard off of a petabyte of data. You're going to pre-process it in chunks using something like Dagster's partitioning, right? That's the way to do it. And that would work pretty well with something like MotherDuck. There's no free lunch, right? There's no way to have a fast and cheap way to process a petabyte of data, right? You have to do it incrementally. And so if your problem doesn't split up very well, and you do in fact have a petabyte, that'd be hard. All right, Peter had a question about DuckDB to Power BI. Well, we're just now launching our Power BI connector. It's compatible with DuckDB 0.10.2. MotherDuck right now is in the process of updating to DuckDB 0.10. So the Power BI connector works great with open source DuckDB today, and very soon it'll work great with MotherDuck as well. So we're excited about Power BI capability. That is a Power Query connector, so anything Power Query will work. So that's Power BI, that's Excel, Power Pivot, both should work. Please let us know how that goes. We're actively contributing to that connector. We put that one together. So we would love your feedback. All right, Tim had a question on microbatching. That's a great question. I'm not sure we have a perfect set of documentation there on microbatching. I think in general, there's two sizes to think about with DuckDB. A vector size is about 2,000 rows, and a row group size is about 100,000 rows. So a vector is the size that we do throughout the engine. Every calculation, if you take column 1 times column 2, we do that 2,000 things at a time in the engine. And then the row group size, 100,000 rows, is how we compress things and store things. So if you kind of do calculations and processing, somewhere around 2,000 rows is going to be efficient, 2,000 or more. And then if you're storing that data, it helps to store it in batches of 100,000. So those are some rules of thumb. All right, other great questions. Paul Simmerling asks, do you plan to make MotherDuck available using storage and compute in the EU? Yes, we absolutely do. We recognize that's important, and data sovereignty is important. Today we are in US East 1 on AWS, so that's the best place to put your S3 buckets for loading into MotherDuck. We do have it on our roadmap to scale across the world to various regions. We're excited about it. Thank you for the very good questions. Other questions? All right.
Last chance.
Yeah. We need the Jeopardy theme song. Always need it. We'll get it with quacks. It won't be annoying at all.
Cool. Well, that might be it. Well, yeah, thank you. Oh, one more question.
GPU question. I did miss the GPU question. I promise I'm not avoiding it. Will DuckDB support GPU processing? So that's a good question. It's not on our near-term roadmap or really our long-term roadmap. The reason is that the types of workloads that databases have really stretch what GPUs are capable of. GPUs want repetitive calculations of the same type that are predictable, that don't have a lot of branches. There's a lot of things in databases that are very heterogeneous. They're very variable, and that tends to not work very well with the GPU. There's also bandwidth limitations of getting things over to the GPU, and the memory size that you have available in a GPU is much less than what you have on a 2 terabytes of RAM server type of thing. So we keep our eye on that space. We're a bunch of, I'd say a huge fraction of the company are big database nerds. That's me. I love being a database nerd. I'm not writing the database code, but I'm a fan. So we watch that space very carefully. And if there is some kind of switch that flips where there's a huge differentiator, we'll look at it. But today, there isn't really a big benefit of GPUs for databases that we can see. And I have asked that exact question before of the founders of DuckDB, and they gave me a similar answer. So it's a very valid question. Thank you for asking. And the reminder, really appreciate that. Yeah, if anyone else has any questions that we missed, ping us again, please.
Any more buzzer beaters? And if you have any questions that you think of later, you're totally welcome to hop on either of our respective Slacks or GitHub discussions, and we'll be very responsive there.
Yes, I think MotherDuck Community Slack is our best bet. You can also send us an email at support@motherduck.com, and happy to chat. Thank you for the
Cool.
great questions, folks. It's really great to have such great questions, and great to meet you all virtually. Stay in touch.
Yeah. Thanks, everyone. Hope you learned something new and interesting.
Welcome to the flock.